Hello, everybody. Welcome to the iSystem webinar about ETAS RTA-OS profiling. Today, this is more a tutorial, so we will make a lot of live demos. Short introduction. My name is Errol. I'm the moderator. I will take your questions so that Felix, our speaker, has enough time to demo and to speak to you. So during the webinar, you're muted. You can use the question tab and write down your questions, and we try to answer them on the fly or at the end of the webinar. The webinar slides can be already downloaded. You can use the handout tab to download now. And we also record the webinar so that you have also the opportunity to listen to it again. As I said, after the webinar, a couple of questions will be answered by Felix and the rest by email. Okay, Felix, a lot of demos today. Go.
Thank you very much, Errol. Yeah, so the idea of this webinar, as Errol has said, it's rather technical and it's more like a tutorial. So the idea is really for you to be able to follow the steps with your own setup. So I will talk not too much about like why we are doing that or the background. I will really focus on the configuration. So the goal is then at the end, you will be able to set up a running task ISR profiling in WinIDEA. That's what I call the hello world use case of operating system profiling. Then we will talk about task state running ISR and what the difference between the two is. We will need a tool called iTCHi to do that. You will understand when manual hardware trace configuration is required, and eventually you will be able to utilize that knowledge to analyze the runtime behavior of your ETAS RTA-OS application. So again, some remarks. This is specifically about ETAS RTA-OS. So if you're not using this operating system, like look for one of the other webinars where we focus on microcontroller and AUTOSAR. This is about ETAS. In general, it's all OSEC AUTOSAR, but there are specific differences. This is why we have a specific application note and a specific webinar for each of the operating system. Again, I assume that you know what we're talking about. So this is about OS profiling and tracing. If you're not familiar with these topics, please watch the other webinars and then come back to this webinar later. And we will demonstrate all the steps that are required for the configuration live. So this is really detailed. The idea is really that somebody can watch this video and follow through with the steps again. So if you're not interested in like a really detailed walkthrough, then this is too low level for you. Again, then I would recommend watch some of the more higher level webinars that explain the general concepts, okay? So with that being said, I will have a short introduction. Then we will first focus on running task ISR profiling, task state ISR profiling, runnables, how you can record runnables, which are part of the RTE. I will briefly mention ETAS MPU-based hypervisor profiling at the end. I won't demo this, I will just mention it so that you're aware that we support this use case, and we will have a short conclusion at the end. So just as a really quick reminder, the goal is to analyze the runtime behavior of our application. In general, we are interested in three main entities or objects to do that. Tasks. Ideally for tasks, we get like all the task states so that we can argue about events like activate, running, suspended, and waiting. We want to observe ISRs, potentially category 1 and category 2 ISRs, and we want to analyze runnables, okay? And once we get a timeline view like that, where we have all these events, we can do a lot of different types of analysis. And again, if you're not familiar with that type of analysis, please watch the AUTOSAR classic profiling webinar where I explain all this stuff in more detail. But the goal here is to configure our WinIDEA workspace so that we get this result as shown on the screen here, and go through the steps necessary to do that. So for each of those three use cases that we cover, running task, running ISR, task state, running ISR, and runnable, I will go through 3 steps. We will kind of discuss the initial setup or like kind of the requirements that you need in order to handle that specific use case. Then we will go over the steps to do that, first in theory and then live in WinIDEA. And then finally, we will analyze the results and talk briefly about what you see and what you can do with the outcome. So I hope that makes sense for everybody. And then we are ready to start with running task, running ISR profiling. So you can already see that the slide is kind of intense. There's a lot of information. I was thinking about splitting it up, but the nice thing about that is that if you're watching this webinar later, you can just stop this and then you have all the information, or you can also download the PDF. And maybe I recommend downloading it and opening it on your second monitors, just so that you can follow along when I demo in WinIDEA. So the idea of running task, running ISR profiling is to get the information about, as the name says, the currently running task and the currently running ISR. So in order to do that, first we need a running, working ETAS RTA-OS application that we want to analyze. And ideally, we already have a WinIDEA workspace that we use to download and run and debug that application. So that's the first requirement, rather obvious. The second thing we need is data trace capability. Ideally, running task, running ISR profiling is done via data trace, and I will talk about that in a second. So if you don't have data trace, there might be other ways of doing that, but ideally you have data trace available. And then finally, you also need a so-called RT file. So RT file is OSAC runtime, or ORTI file is OSAC runtime interface file, and it gives the debugger information about the running task and the running ISR variables. So if you don't have the RT file, go to your RTE operating system configurator and enable RT debugger support. And I've posted a little link here that explains how to do that if you haven't done it yet from the ETAS homepage. Okay, so once you have those files available, let's see why we even need this RT file. And here on the right side, you can see that RT includes two attributes that we're interested in: running task and running ISR. And if we then go into the RT file, it looks somehow like this. For each of the cores, if you have a multi-core system, or for the single core, if you have a single core system, you have a running task attribute, and that points to a symbol, like to a variable inside your application. And so you can see there's some struct here, OS control core info, and the struct has a running task and running ISR variable. And then by data tracing this variable, by recording the right access to those variables, the profiler can reconstruct which task and which ISR is running at a specific amount of time, at a specific point in time, I mean. And the mapping from this running task variable to the name of the task is also part of the RT file. Okay, so once we have that available, we can add the RT file to WinIDEA. We open the analyzer and create a new analyzer configuration. There are a couple of steps we have to do there. It's not too difficult. The analyzer will actually be able to do the configuration of the hardware trace itself manually, but optionally, we can also try to do the data trace configuration by ourselves, so that we can make sure that it's optimal and as efficient as possible, and also just so that we get an understanding of how a data trace configuration works. Note that this step is specific to the architecture that you're using. So today I'm using a Chorus 4M target, because that's the target that my ETAS demo application uses. So this step might be different depending on the hardware you're using. And then finally, we can start the recording and analyze the trace, and it should look something like down here. With that being said, let's take a look how that looks in WinIDEA. So I have a hopefully running application. Let's see, it still works. So that's my first requirement. I have a running ETAS RTA-OS application, and I have a RT file located here in my applications directory. So the first step, as we said, is adding this RT file to WinIDEA. So in order to do that, we go to Debug, Operating System, then select New, and you can see we support a couple of different operating systems here. In this case, we have OSEC AUTOSAR. We give it a name. And then there are two fields here. The first field is the RTOS description file type. So in this case, we have RT. We will later use iSystem.xml. And then there's also RT.xml. So the reason I will talk about why we need the iSystem.xml later, and I mentioned that RT was part or is part of the OSEC standard, which is obsolete. It's just supported in AUTOSAR. And in the future, there will be a new format called RT.xml or RT-RXML, and we already partially support that, and it's already partially in the standard. Last time we got a question about this RTA RXML, so that's a work in process. In the meantime, we mostly use iSystem.xml for more complicated use cases, but in this case, we just want to add a RT file. And I go to my application directory. So the RT file usually, no, I can't find it. Let's see. There it is. Usually has a ORT or actually an ORTI file ending. So I select that file. And then after selecting it, I always have to make WinIDEA aware of those changes. So I can do either a load symbols or download to make sure that WinIDEA reloads the operating system description file. So I had some issues with my target before, but now right now everything is running fine. So I have added the RT file. The application is running now. So now the next step is, let me close this quickly. The next step is to open the WinIDEA Analyzer. So the WinIDEA Analyzer under View Analyzer is the tool or the view in WinIDEA where we do all the trace and all the operating system and all the profiling, timing analysis in general. So I open that, and then it has the tendency to open in a separate dogging area here. So I like to drag it, drop it into the main area, and then it will look something like that. And now what we have to do is, and again, if you're a little bit overwhelmed, I recommend downloading the PDF and following along on the slide where we have all the steps explained. The next thing is to create a new configuration. I recommend always creating a new configuration, never use the default one. So in this, here you already see I have some fallbacks in case they do anything wrong, but now we want to create a new configuration actually. And what we are going to do is we're going to do running task, ISR profiling. And then we need the profiler, so that's used for the timing analysis. We don't need code coverage in this case. The code coverage is based on program flow trace, and we are not worried about that right now. And then we actually want to do an automatic trigger configuration. So we want WinIDEA to do the configuration. So that's why I have selected automatic here. Okay, and then this menu opens, and I always say that, but it's really important to understand that you have to focus on these two tabs up here. The hardware tab is where you tell the microcontroller what it should record, and usually you do that by selecting manual trigger recorder configuration and clicking configure. If you don't have that selected, then WinIDEA will try to do it automatically for you, okay? And we have profiler enabled, so that's good. Then we can switch to the profiler tab, and this is where you tell WinIDEA how to analyze the data that comes from the hardware. So in this case, we don't want to analyze program flow trace, so we don't want code. We also don't have any network tracing like our CAN add-on module connected to debugger, so we don't need network, but we want to record the operating system. So let's check that configuration. And it looks like that. So first thing you notice is our operating system that we just added under debug operating system is here. And then it shows us some of these objects that are part of the RT file. And if you open that document by ETAS that I showed you earlier, there is actually an explanation about what those different objects mean. So right now, what we are interested in is tasks and ISR. So I unselect OS signaling here for now. Don't want to go in detail. I don't have any category 1 ISRs in this application, so I'm not going to select that. And as you can see, I have 2 cores here. So I have to make sure that for both cores, I have tasks and ISRs selected, okay? So this is how your configuration should look like. And if you click here on one of the tasks, then it shows you some more information, specifically like the variable that is used for the tracing and yeah, some other information here. Okay. So that's what we have to do here. And then let's click OK and OK again. And then maybe before I forget about it, I want to explain one further setting because that always confuses people a little bit. So the first thing you notice, you can now see that the active configuration is shown here. And if I want to edit the configuration that is currently active, I just click on the hammer. So the hammer is the shortcut for editing the current configuration. And I want to point out that there is a recording size limit here on the hardware tab. And that recording size limit is actually the size for the buffer on your machine. So that means that's not the buffer on the microcontroller or the buffer on the blue box, that's the buffer on my host laptop right here. And it means once 1 gigabyte of trace data is recorded, the trace recording will automatically stop. So since we don't have a lot of data here, we just have like 4 variables that we're tracing, 1 gigabyte actually equals a rather long time. So that's the recording size limit. And then also here under profiler, you can also limit the session duration. So that means after we have recorded for 3 seconds, if I select that, the profiling will automatically stop and so will the hardware trace itself. Okay, so just you understand those 2 options for configuring how much data you want to record. Okay, so with that being said, now I'm actually done with configuring this use case and I can go ahead and start the trace recording. And so there are a couple of things you will notice here. The trace recording size increases here. Then down here, we see how much data we have recorded. And then the file percentage, this is actually the fill status of that 1 gigabyte. And as you can see, it doesn't increment. That's because 1 gigabyte is a lot of data and we are not recording a lot of data here. As I said, it's just 3 variables and there's not too much going on in this application. So let me stop and show you what we have. So first thing I like to do is I like to click this auto zoom all button just to see everything that's going on over the complete duration of the trace. And then I also have my filter active here. So if I don't have the hide areas with no activity here, it looks like that. You can see on core 1, there's no ISRs, but there are some tasks here. And then similarly on core 0, we have this milliseconds, which is like a counter ISR, and we have some tasks. And it's this ETAS Pizza Pronto demo application. So what's happening is on core 0, there is this write code. So it's kind of like a developer. He or she is writing code. And then they decide they get hungry and they order a pizza. And then once the pizza arrives, they eat the pizza, and then and of course they do that in parallel to writing code, so to not waste any time. And then eventually they stop writing code and go to bed. And then the next day they get up again and continue the same process, right? So that's kind of the application here. So what I want to point out here is the blue color means that more stuff is going on. So we have to zoom in to really see what's happening. Red means that a specific object is active. The light red or pink color means that the task is preempted either by another task or by an ISR in this case. And then the gray color means that the task is currently not active. And let me add the filter. So with this, all the objects that are not actually active are hidden. And you might wonder what the green color means. So green color is if an object is active, like the idle task here, and this idle task, so WinIDEA knows that the idle task is not actually doing any load. So that's why it's shown as green. So it means the idle task is active, but it's kind of the idle object. You can see similar for the ISR green, it's shown in green. So it means the object is active, but it's the idle object. So it's just a visual indicator for that. And now the challenge, so this is already nice and good, but the challenge is with running task profiling. If we zoom in here, you can see the write code task stops and then the order pizza task starts. And in between, we have this gray gap. And the problem is we don't really know what this gray gap means. So there are two scenarios that we could argue could be happening. The first one is write code terminates, then order pizza is started, terminates, and write code is started a second time. Or it could be that write code is preempted because order pizza has a higher priority. And then once order pizza is finished, write code continues. And we don't really know, like in this case, it seems highly likely that it's the second case, that this is a preemption, but this might not always be clear, especially in a more complex system. So this brings us to our next use case, actually. So again, I won't focus, like there's some other things we could do here. We could analyze the statistics and so on, and we could look at the raw trace here, but that's not the purpose of this webinar. If you don't understand what's going on here, the AUTOSAR Classic Profiling webinar is a good one to check out. But let's finish with this note here. We don't know what's going on here really, and as I said, this brings us to the next use case. So let me open that slide. And again, I know this is a lot of information, but it's okay. When you watch that later, you can pause. But we said the problem is we don't really know what the tasks are doing there. It could be a preemption, could be a termination. We don't really know. So this brings us to the next use case here, task state running ISR profiling. So again, we need a ETAS application, obviously. We need RT file. We need a data trace capability. And then we need a tool now called the iSystem Trace Configuration Helper. And so why do we need that? Ideally, we would know what exactly is happening in those weird gaps in the trace. And to do that, we can record the task state. And the task state gives us the information about what a task is doing when there is a gap. Like, is it preempted? Is it waiting? Is it suspended? So the task state, luckily, is also, and let me add the laser pointer here, or the pen. Well, the pen is actually nice. I can do some drawing. How do I delete that? I don't know. Anyway, the artifact gives us an attribute for each task. There is a state attribute. And in the past, the state used to be like a simple variable, like there used to be a so-called state array, and then each task had a field in that array which showed the state. But you can see here in the ETAS RTA-OS case, the state is a little bit more complex. It's actually, we are comparing the running task variable and check if that task is running, and then I don't know, we do some other stuff, some shifting, some bitwise ending, and so on. And you can see it's actually, we have three variables that are used here: running task, ready task, and waiting task. And if we could data trace all these three variables, then we could add like the information from the three variables together and get the state that we want. Okay. In order to do that, we have to configure the data trace to record all this information, and we also have to tell WinIDEA how to interpret the data. And the way we can do that is via so-called inspectors. That's like a special tool in WinIDEA that allows you to express like more complex information like this. And in order to create the inspectors file, we have a tool that's called iSystem Trace Configuration Helper. It's a Python script that gets packaged into a iTCHi bin executable. You get it in that form. And that Python script can help you with doing and creating this configuration. So we will create an inspector file, and then we will create a so-called profiler XML file that I mentioned before, and that will allow us to do this use case. So in order to do that, again, you need the system trace configuration helper. You start by creating an empty configuration, and then for this use case, you need to configure the RT file, profiler XML file, and the inspectors file. You will add that to this iTCHi.json configuration file. We will do that together. You need to specify the task to core mapping, and we need to specify a default state, and it's kind of shown here on the right side. So this is how our configuration will look like at the end. Then we will generate a profiler XML file, and I should have said generate profiler XML and inspectors by running this command here with iTCHi. Then we will add this profiler XML to WinIDEA. We will create the trace configuration, and we will have to do that manually because it's so many variables. WinIDEA will no longer be able to figure out by itself like what it has to record and what not. So we have to do it manually. And then finally, we also have to add these variables to the data area. And this looks like, so this is the part where we add it to the data area. And I will talk about why this is required once we're doing it. And those steps are rather tricky, like there's some caveats. For example, this waiting and ready tasks may be written from multiple cores, cross-core writes possible, so we have to take that into consideration when creating the trace configuration. Okay, so it looks complex. It is a little bit complex, but it's not that hard. I'm sure you will all be able to follow along quite easily. And once we have that done, we can start the recording, and we should now be able to see the task states in addition to the running ISR trace. So the running ISR actually works exactly in the same way as before. Don't need the annotations. And then let's go back to our workspace. So if you get iTCHi, you get an empty directory. You don't get an empty directory. Hopefully, you get a directory that has this iTCHi executable, and then a README, which also explain all those commands that I will talk about in more detail. So don't worry if you don't get everything, but you can check out the README. And then I have some fallback files here in case something goes wrong. But let's just try to do it from scratch. I open a terminal, and then I can start by just running iTCHi, and if I don't specify any flags, it will give me a help output. And then first thing I like to do is I can create an empty configuration by using this write default config flag. And that's always a good point to start, because then you don't have to worry about if like your JSON is formatted correctly and so on. You can you can just use that file as a starting point. Okay, so if we open that file, it looks like that, and you can see there are a lot of different use cases supported. So there are a lot of information here. I will just go ahead and open the final file now, how it will look at the end, and then talk through it. I think that makes more sense. But usually what I like to do is I'm like, okay, in this case, I actually don't need running ISR, so I would delete that. And I just like to clean it up and delete the stuff that I don't need. So let's don't do that now. Instead, I will just open my existing configuration to save a little bit of time. And as you can see, I have task state inspectors.json prepared here. So I'm gonna, oops, that's, I don't want the inspectors, I want the iTCHi config. So that's what I want. Okay, so it looks like that. So let's quickly walk through it here. we need to specify the RT file. So iTCHi needs that in order to create the inspectors and have access to the task state attributes. Then we need to specify a path to the profiler XML. And I really like to have the profiler XML in the same directory as the JSON file. And there is some reason for that. Like the reason is how the path handling is done internally in iTCHi and in WinIDEA. So if you don't want to get into any troubles with the path handling, just don't add a relative path here. You can do all the other paths as relative, just and this is obviously, of course, a relative path too, but just do it directly inside the same directory as the JSON file. So the iTCHi is actually going to change directory into the JSON file directory, and then it creates the profiler XML here. So just do it like that, and then you won't have any issues. So that's the profiler XML. Then for the task state profiling, we have to help iTCHi in case of the ETAS RTA-OS. It's not able to figure out where the tasks are allocated automatically. So we have to provide that information manually for each of the tasks in the system. And if you have more tasks, it's going to be more tedious. Luckily, I just have three tasks here. For each of the tasks in the system, you have to tell iTCHi like where it's allocated. So that's what I did here. I have the task name and then the core ID. Okay, so you have to do that manually. And then finally, we want to record the task states via the inspector. So there are a couple of attributes that we need for that. And constant variables is not required in this case, so we'll just skip it, just leave it empty. The default state is suspended. And then we need to provide the path to the inspectors file. And just to make it easier, I have also placed that inspector files in the same directory as the configuration file. And then finally, we need this parent area template, and we don't actually have to change that value compared to the default configuration. So this is how it would look like. Again, what you really have to do is specify this mapping, specify the names here. Again, if you're doing this by yourself, just copy the names here, like those names should be fine. And just make sure that you adapt the path to your RT file depending on your application. Okay, so once we have done that, let me close this default file, and then I will actually just quickly copy that and rename this to the iTCHi JSON file. And then the next step would be, if we open the help again, or it's actually still open here. So by default, iTCHi always searches for iTCHi.json in the current directory. So by renaming that file, I don't manually have to add the, let's clear this. Okay, that was done because I need the help. So by changing iTCHi.json, by giving it that name, I don't have to manually specify the path to the config file. So that's why I did that. So now we can actually create the profiler XML and the inspectors file. So to do that, I use this flag here. So it's task state complex expression. So that's what we want to do. And then once that command has finished, I will go ahead and close this terminal for now. And you will notice that this inspectors JSON file and the task state profiler XML has been regenerated. Okay, and the inspectors JSON file as well as the RT file are actually referenced both. They're both referenced from the XML file itself. So you don't have to worry about that anymore. All right. So now let's go back to WinIDEA, and now we want to add that profiler XML file. So I go to debug operating system. I delete my current operating system, and then I create a new one, like AUTOSAR, ETAS profiler XML. And I switch this to iSystem XML, and I select my task state profile XML that I just created. Okay. And again, I have to do a load symbols. Let's see if this still runs fine. Oh, I'm lucky. Everything's perfect. That's good. And now I go back to the analyzer, and now I have to create a new configuration. And this is actually the trickiest part now. So I think I will actually use my fallback here just so that I don't screw anything up and waste time, but I will still walk you through all the steps. So normally, since you don't have my fallback, what you will do is you create a new configuration. You call it task state running ISR, and you select profiler, you don't select coverage, and then you do a manual configuration here. And you will get a window like that. And this is now hardware dependent. But what we have to do is, because what we need to trace now is, we need to trace, as I said here, I just want to show that again so that you understand what we are doing. We need to trace the running task variable. We need to trace the ready task variable and the waiting task variable for all cores in our application. So we manually, whatever target you're using, tri-core, PowerPC, RJIT 50, you have to find a way to use data trace to record all those variables. So in our case, on the ETAS, on the cores for AMP, it's actually not that difficult. You can see we have two CPUs here. CPU 2 is core 0, CPU 0 is core 1. That's just how it is on the PowerPC. And so I'm going to enable the trace data. And then I have this data trace comparator. So you have those in one form or another on all the targets. And what I'm going to do is I will go to OS control core info. And it's really nice because, as you can see, running task, running ISR is both part of the same structure here, and waiting task and ready task is too. So to make my life really easy, I can actually just select this field here, and it will automatically record all the write accesses to all the sub attributes. And this may be a bad idea if your data trace bandwidth is limited, because you're getting all those write accesses to the attributes that you don't actually need. In my case, I have enough bandwidth, so I can do that. And I can make my life even easier. Since this is for core 0 and this is for core 1, I can just select this whole object up here, and then I will get all the write accesses to any of those attributes, and using a single data comparator. So I just select this, do entire object, and I want to get the write accesses, and that's all I have to do. So it's actually not that complicated. And I just want to point this out one more time. I know it sounds like a broken record. We do that to record running task, running ISR, ready task, and waiting task. We don't need all the other information, but it's the easiest way to configure it. And now I could simply do this for the second core. So data, select this entire object. Okay, done. That's actually all I have to do. It works pretty similar on most other architecture, just that those menus will look a little bit different, okay? So now the next step is, so what we did now is we made sure that we record the actual values. So now there's one more thing. In order for iTCHi to be able to, so maybe let me just do a recording here and let's see how that looks like. So let's stop it. So you can see WinIDEA is showing us the running task and the running ISRs, but it's complaining down here. There are inspectors and there are data areas that could not be found. So what's going on here is that the inspectors reference the data areas that we have just, like the variables that we have just configured that should be recorded. but they are not part of the profiling yet. So what we do is now is we create data areas for those variables, and this is where I'm actually going to fall back to my pre-created configuration. But what you have to pay attention for is this is the area that WinID is looking for, and the way we configure that is, let me switch here, task state running ISR. The way that we configure that is, we go to profiler, and then again, let me check if this is okay. So everything is selected here. This looks different now because we're using the profile XML now. And then what I have to do is I have to select data here, okay? And then I have to add those data areas. And you can see for each of the cores, I have added the data areas, control core 0 and then P0. There's a P1 for the struct for the field 0 too. I don't fully know when you need that. I know that for my application, I don't need it, but it might be like if you have more tasks, that you have to add P0 and P1. In this case, like this is actually the right configuration. And if we double click on that, it's actually a little bit tricky because we have to do some manual work first. First, we have to select the object that we want to trace. So let's say if we want, not the object we want to trace, the object that we want to visualize. So in that case, we have ready task P0, okay? We select that, and then we have to change the name, the description. That's how it's visualized in the profiler timeline. And the reason for that is, firstly, you can see there are a couple of brackets here, and those brackets are not in the RT file, and or parentheses rather. And so we have to remove those parentheses. And then secondly, you can see that ETAS adds this postfix here to like indicate that, I don't know, that is an unsigned variable probably. And so iTCHi is expecting that to be in the description. So what we have to do is we have to copy the string up here, remove all the parentheses, and add this U here. And again, if you're not sure how this should look like, it will show you, it will complain to you in the output. And that's what we have to do for each of the variables. And like, there's no way to like figure out how to do that automatically. So you just have to do it manually once, and then you can save that configuration and reuse it. Okay. So you see, I actually did that for all the ready and all the waiting task attributes. And once we have that done, we can go ahead and do another recording. And so hopefully I haven't screwed anything up. Let's just record for a couple of seconds and then do the auto zoom. And then now what you can see here is WinID now shows me this ready task and waiting tasks variables. And then if I look at the trace output, at the output window, you can see that iTCHi is no longer yelling at me because those objects are missing. Now they are actually here and they can be resolved. And finally, what that allows us to do is, now if we go back to our initial motivation and look at this write code and order pizza, so let me kind of hide the other stuff for a second. You can see I can expand these areas now, and maybe let's just do one. So there is this SAR that's here for historical reasons, as they say. Just ignore that. You don't really need that for now. But you can also see there are some inspector objects now. And so those inspector objects actually indicate the different OSEC operating system or AUTOSAR operating system states. And maybe I go to write code here. And what you can see now is really the complete state model. So here in the beginning, the task is not active, and we can check why it's not active. Oh, it's actually suspended, and then it gets activated, so it goes to the ready state right here for a couple of milliseconds or microseconds, maybe even. You can see it's activated for a certain time. Then it goes to running, And then when it's preempted by an ISR, it goes to ready ISR. So that's nice and good. So we can like measure how long this task spends time being interrupted. And then finally, here's our gap. And now we were wondering what's going on in our gap is up here. What's going on in that gap? And now if we look down here, oh, it's actually not suspended. It's in the ready state. And here. And that gives us the information, okay, this is actually a preemption. The task was running. It gets put into the ready, then the other task is executed, and then it's resumed. And really, we have the knowledge about what's been happening here. Similarly, if I go to the other core here for a second and look at Eat Pizza, you can see that Eat Pizza is actually an extended task, because when it goes from running, like it stops running here, and then after it stops running, it's not going to suspend it, but to the waiting state. So it's waiting for an event. It's an extended task. So we get that information now. And so this is now good for a couple of advanced analysis techniques. So now we can calculate stuff like the activate to activate time. We can calculate the response time metric. We can calculate the CPU loads with more precision, because we know like all the preemptions by the ISRs and so on. So this is really what we want the task states. And we had to go through a little bit, like we have to jump through some hoops, I guess is the idiomatic expression, to get here. But the reason for that is it's just a complex state expression, and WinIDEA needs some help to figure out how to interpret that, okay? So that's why we had to do all this work. And maybe one other benefit that we get from doing this configuration, iTCHi automatically adds the information to the profiler XML about how to export a BTF trace. So if you want to do timing analysis in a third-party tool, like the Vector Timing Architects tool suite, or Incron, or SimtaVision, Luxoft, however those tools are called, you can go to export and then specify a name, select BTF, make sure entire session is selected here, and you can record yourself on, you can export yourself a nice BTF trace, okay? And this BTF trace just contains the information about when all the tasks, ISRs, and so on are started and stopped. All right, so now running out of time a little bit, but this was the hardest use case. So I hope this information will be helpful for you in the future to do this configuration by yourself. If you're wondering where you get iTCHi, so we're still working on adding iTCHi to WinIDEA itself. It's not available yet. It will happen within the next 1 or 2 months, I would estimate. If you need it, just contact one of our FAEs or support or me, and then we will provide it to you manually. Okay, so let's take a short break and then do the last 10 minutes. We will do one last use case. Hope all of that makes sense. The last use case is runnable profiling. So if we want to get deeper insight into the application, then we might be interested in runnables. So there are 2 ways of recording runnables. One is via program flow trace, and the other way is via using some instrumentation. So in this case, we will focus on program flow trace. So we need program flow trace available to do that. And we need the iTCHi again to help us with the configuration. In this case, we can start with an empty iTCHi file, or we can reuse the previous file. We add the runnables that we want to analyze to the iTCHi.json file, regenerate the profiler XML, and then again, we need to add the profiler XML to the operating system menu in WinIDEA. We have to make sure that the runnables are selected in the OS setup. That's what, let me add my pen here. That's what we did here. When we run iTCHi, we have to make sure that this time we specify both flags, the task state and the runnable program flag. We could actually do it one after another, like that would work fine. Like iTCHi doesn't delete objects that are already there. So that's kind of nice, but we can do it together or one after another. We have to make sure that program flow trace is enabled. And then once we do that, we will be able to see the runnables. So let's just do that quickly. So let me open our iTCHi.json and then task states runnables. So this is the same JSON file as before. The only thing that you will notice is that there's another section here called runnable program flow. There is also another attribute runnable instrumentation, and we add a list of runnables here. So in this case, in this example application, I don't really have a lot of great runnables, so I just added like this counter and delivery time function. So those are not really runnables, but I'm sure you know what a runnable is, and if you have a serious application, then you will have those runnables. So I will just, I guess, copy and paste that over in my iTCHi file here. Oops, there we go. And this is JSON, so we have to be very tedious with our commas here, or very careful. So we need a comma here. We don't need a comma at the end, like that would be a syntax error, right? So I have to make it like this. And then we can go ahead, open our PowerShell again, and then we do task state complex expression, and now we add runnable program flow. Okay, now hopefully these two files should be updated again. Yep, nice. So we go back to WinIDEA, do one load symbols. We still have the same profiler XML selected. So if you don't have the profiler XML selected, don't forget to do that under debug operating system. And now what you will see is if you click on the hammer OS setup, I have another item here called runnables. So I select that. It shows me the runnables that I have configured. And I click OK. And now there's one more thing I have to do is I have to enable the program flow. So I go to hardware, configuration, and I activate the program flow trace for both cores. And then I can run the target and run the profiler. And as you can see, WinIDEA is really a reliable tool. I didn't get any issues here at all. I'm really happy about that. And now something will go wrong probably. I hope I didn't jinx it. So as you can see, we don't see any runnables yet. That's because we have to unselect this hide areas. And now you will notice that there's this runnables section here. And if I expand that, it actually shows me those runnables that I have added here in this separate area. The reason, like when I select hide areas here, it hides this area because there's no activity. That's a little bit annoying, but not a big issue. So we have the runnables here now, and you can understand how this would be more useful if I had like actually more runnables and serious runnables. I could analyze those here. And now if we export the BTF trace, then those runnables will actually also be part of the BTF export. So for example, if we search for this milli increment counter millisecond here, you can see that that is part of the BTF trace now. Okay, so this was really quick, but it was also not too complicated. We just added the runnables here that we want to record. That has the effect that those runnables will be added to the profile XML file, and then WinIDEA will show them to us. We just enable program flow trace, and it will show us the runnables here. Of course, we could still also just show code here, and then for us to be able to do that, we have to select code here. And then if we do a reanalyze, then we can still see all the code up here. But if we want to focus only on the runnables or export the runnables to BTF, then we have to explicitly add them to the profiler XML via iTCHi. Okay, so let's go back to the presentation and let's wrap this up. One last use case I want to mention is we had a specific, so ETAS also provides a MPU-based hypervisor. It's kind of a lean, efficient hypervisor that is based on a memory protection unit. And we had a big project where we wanted to record a hypervisor aware trace. So it looked something like that, where we had a running virtual machine attribute. So WinIDEA was able or is able to record which virtual machine is running. And then for each virtual machine, we have another object that shows us the tasks that are running within that virtual machine. And this use case is a little bit more challenging to configure, so it's not supported by iTCHi. You have to do it manually, and we haven't had a whole lot. Like, we actually only had one major project where we are doing that. But if you have a use case where you want to analyze your ETAS MPU-based hypervisor, I forgot the proper name, ETAS RTE hypervisor, then we can help you with doing that. So just contact us for further information. Okay, MPU-based hypervisor support. Not, and there is actually an application note about that too, but it's rather a lot of configuration effort, I would say. So just feel free to contact us if you need this use case. So conclusion, we talked about the three major use cases. We saw that for running task, running ISR, trace the configuration is rather simple. For the other use cases, it's a little bit more work, but we provide iTCHi, and iTCHi actually does most of the heavy lifting. The good thing is, once you have this configuration, once you have the iTCHi JSON configuration, even if you change the OS, like if you regenerate the RT file, or if you add more runnables, you just have to do like rerun iTCHi, and it will automatically update all the configuration. So it really makes it much easier compared to how it was in the past. Ideally, in the future, we would have RTRXML, and it would do all the stuff for you, but it's not there yet, unfortunately. So that's why we still have to do this manual work. There are other use cases that you might want to consider, depending on your setup. So if you don't have data trace available, you might still be able to record running tasks, running ISR information via operating system hooks. So this would work by adding instrumentation to the hooks, and then, so for example, on the RJ50, there's software trace. So you add software trace instrumentation to the hooks, and then by doing that, you would be able to record running task, running SR information, even without data trace. Of course, the caveat is that you need some instrumentation to do that. iTCHi doesn't really support that use case, so you would have to do that manually. We have like an example project that you could use if you're interested in that use case. And then another thing I want to mention is, if you don't have program flow trace available, or if you don't have a powerful version of program flow trace available, like recording program flow trace for 2 cores, as I just did, is kind of unrealistic in a real world scenario, because usually there's too much data. So to work around that limitation, you could instrument the runnables via the so-called virtual function bus RTE trace hooks. And the way that works is this virtual function bus trace hooks, there's a start and return hook for each runnable. We can add a little bit of instrumentation to that variable, to that hook that writes into a global variable, and then we simply data trace that global variable. That generates much less load than a program flow trace, and that would then also enable you to record runnable information without program flow trace. And the good thing about that use case is iTCHi can help you to generate this instrumentation automatically, even based on user templates. So it's actually not a lot of work to set this use case up. Currently, we support the microSAR and the Electrobit AutoCore RTEs. I don't know if I don't think ETAS has their own RTE. I think they usually use one of the other RTEs. So if you're using the microSAR or the EB so they are vector microcontroller or the EB AUTOSAR RTEs, you can use this feature and rely on some instrumentation. And then finally, I would always start with this hello world running task ISR profiling use case and then go from there. Even if I start with customers, always start from that and then continue with one of the more advanced use cases. All right, 4 questions, webinar@isystem.com if you need any further information. And then finally on the last slide, I have some further links here. We have an online trace tutorial that is really good. So if you didn't understand what I was doing there with regards to data trace and program flow trace, what that stuff is about, check out this online tutorial. It's really nice to get started. We have some application notes. We actually don't have one about ETAS RTA-OS profiling yet. We're working on that. And then check out the other webinars about introduction to tracing and AUTOSAR classic profiling if some of the stuff didn't make sense to you. And with that, I needed exactly 1 hour. It was a lot of information, so I hope you can go back to those parts of the video that are relevant for you in the future. And let's give it back to Errol and see if we have some important questions.
Yeah, thank you very much, Felix. There were indeed questions. Maybe you answered them already, but there was one question. If we don't have an RT file, can I use this method you showed? So they are using DaVinci configurator to generate the OS.
Yeah, you as like in any AUTOSAR operating system, in every AUTOSAR tooling, there is a way to create a RT file. So if you're using DaVinci configurator, I recommend that you look into the microcontroller profiling application node, and that will show you how to enable RT support in DaVinci configurator. If you're using a non-OSAC AUTOSAR operating system, you can still use this, but you will have to do more manual configuration since you won't have an RT file for a non-AUTOSAR OSAC operating system.
Okay. Another question came at the end when you showed the runnable tracing. When you gather runnable data using program trace, is the trace still gathering all program data, or is it filtered so that there are no overflows?
So in this case, I actually I recorded the full program flow data. So it Winner is not automatically filtering only the runnables. And in most cases, that's not feasible. Like you don't have enough program flow comparators on most architectures, or once you have more than 4 runnables, it won't be possible to trace those selectively. So you will have to record a full program flow trace, with all the functions in the system, and then we extract only the runnable information. If that overflows your trace buffer, then you would need you can try to manually adapt the configuration to avoid overflows, or you have to use instrumentation via data trace to get less data. So it's a little bit challenging, and then there's no good general answer to doing that. So the first step is try a whole program flow trace, with all the data. That's overflowing. You can try to manually limit down the areas that you want to record the program flow trace for. If that's not working, you probably need to use instrumentation. So those are kind of the 3 steps.
And at the very beginning, you showed this 1 GB buffer on the host. Is this limited, or what can I do?
I mean, you can see here,
yeah,
it can go up to 1 terabyte if you have that much disk space. So you can literally record for hours if you want. Which some customers do, by the way, even in the car.
Yes. Okay, maybe a last question. You showed us how to set up the system. That configuration is a tough job. how much do I need your help to do that?
I mean, now since you have the video, you can just like watch the video and follow through. And I really made sure to mention all the steps and all the potential pitfalls or caveats, I guess. So should be able to do it by yourself now. If you're not able, like if something goes wrong or you run into an error that you don't understand, feel free to contact us, of course. But I think like with this video and the application notes, you should be able to do it by yourself.
And there's also iTCHi. That helps
And there's
a lot.
also
Right.
iTCHi, exactly.
So more to come about iTCHi in the future. I think that's it, Felix. So thank you for this great presentation. Gives a lot of insight, and hope to have the same kind of seminars in June, tutorials about vector microsar. Registration is online already. And yeah, I have to say thank you to all of you for attending this special tutorial, and hope to see you in June for the next webinars from iSystem. Thank you very much. Bye-bye from my side.
Thank you. Bye-bye.